Okay, EC6 gives us some information and then kind of modifies the information for 3 different scenarios. So we won't film the entire problem solving for all 3 scenarios in this film. Look at some of the other subsequent films to see the other few scenarios in here. Well, let's read the information first. It says, your company plans to issue bonds later in the upcoming year, but with the economic uncertainty and varied interest rates, it is not clear how much money the company will receive when the bonds are issued. The company is committed to issuing 2,000 bonds, each of which will have a face value of $1,000, a stated interest rate of 8% paid annually, and a period of maturity of 10 years. Requirement number 1 says compute the bond issued proceeds assuming a market interest rate of 8%. When computing proceeds, round the percent to the nearest face amount and the annual interest payment to the nearest $100. Also express the bond issue price as a percentage by comparing the total proceeds to the face value. All right, when we go through this problem, we first have to discuss how we calculate bond proceeds. So the goal of what we're doing here is actually calculating the cash or the bond proceeds that we're receiving from issuing the bond. Remember how earlier I told you that up until this point you've been given what the cash proceeds are. There'll be a percentage of face value, 97% or 102% of the face value. This is the point at which we actually calculate what those proceeds are, calculate that percentage of face value based upon our time value of money computations. So interest rate and principal are the 2 components that make up a bond, okay? If we were to look at a kind of time spectrum, with this being the present value, this being the future value, there is a single sum component to what you as an investor are willing to pay for a bond, okay? You're gonna give them cash, they're gonna give you a contract in the form of a bond, all right? So, the amount, the single sum, represents the principal that you will receive in some future amount, but since you don't get it today, again, dealing with this time value of money, since you don't get it today, we need to discount what that amount is worth right now, okay? Because that is a portion of what you're paying for when you buy that bond, right? You're paying for that principal portion that you're gonna get in the future. But it's not worth the same amount that you get in the future as it is today. It's worth a lesser amount. Why? Because of the time value of money, the compounding of interest. This is the first portion that you're paying for. The second portion that you're paying for is interest. With the interest, it's not a single sum amount, but it's what we called an annuity, okay? With this being the present value, this being the future value, and in this bond we had 10 periods, so if we mark these off, and I don't know if this equals 10 or not, but we'll just say it does, okay? 10 periods, at the end of every single period, you're getting an interest payment, okay? You're getting 8% of the face value every single time. 8% of our face value is at $2 million, so we get $160,000 every single period, right? But these happen in future periods, and our question is, what is it worth today? Why? Because we want to know, what is it, the price, what are the cash proceeds that the company should receive for issuing those bonds, or stated another way, that you as an investor would be willing to pay to buy those bonds. Does that make sense? So you're looking to see, what are these future amounts worth today if we were to discount them? In both respects, we deal with the present value. In both respects, we want to know what the present value is of some future amount. But in this principal calculation, we're dealing with the present value of a single sum. And in this present value calculation, we're dealing with an annuity, because it's a constant, consistent, equal payment, okay? So this is kind of conceptually what we're trying to do here. Now let's actually walk through then the calculations. For the first component here, this principal, We have a face value of $2 million. Remember I told you you could work through the algebraic equation, or you could simply take the future value if we're trying to get present value. We want the future value amount multiplied by the present value interest factor. Well, the future value amount is $2 million. That's the principal that you're getting back. And notice how we got the face value. They said that we had 2,000 bonds that we were issuing, and each bond had a $1,000 face value. Okay, so that's where the $2 million comes from. Now we need to take the present value interest factor. Okay? Dealing with the present value interest factor, we first look at our market rate. Well, our market rate that they give us here for this problem is 8%. Notice that I have listed up for you here the stated interest rate. But when we're dealing with time value of money, we're concerned with the market interest rate. Why? Because our calculation, when we looked at this spectrum, right, we were looking at the interest that we're foregoing to calculate back the lesser amount, right? Or the interest that we could use on a lesser amount to get us to this future amount, right? We were calculating the interest that was available on the market. Well, that's why we're concerned with the market interest rate as opposed to our individual specific bond rate, okay? So the market rate just so happens to be the same as the stated interest rate, which I'm going to talk about here in a minute, okay? So we multiply this out times the present value interest factor at 8%. Not because it's the stated rate, but because the market rate is 8% at this problem. So I'll write that out to the side real quick. Market rate is 8% and the periods is 10. So all we need to do is simply go to our table. This table can be found on page C15. It is the present value of a single sum. And all we have to do is scroll on the left-hand side to 10 periods. And then we need to scroll at the top to 8%. And we find that our present value factor is 0.4632. So multiply this out by 0.4632. And we get the principal portion to be worth $926,400. Okay? I'm going to erase this guy so that we can do the second step, which is the interest portion. Okay? For the interest portion, we're dealing with an annuity. Okay? We're dealing with annuity. Notice how right now we've converted future dollars, this 2 million, essentially you can think of it like a translation in a currency. We've translated future dollars into present value dollars. What are those worth right now, right? So the principal portion is the present value dollar. Now we need to do the same thing with the interest, but this guy is an annuity. It's not a single sum amount. So what is our calculation here? Well, it's the annuity times our present value of annuity interest factor. Again, using our market rate times our market rate and our number of periods, we can get the interest factor. But before we go there, we have to determine what the annuity is, okay? The annuity is, in fact, the interest payment. And interest payment meaning cash, not interest expense, but cash is always your face value times your stated interest rate. Well, the face value is 2 million. Our stated interest rate is 8%. So we get 160,000 as our constant equal reoccurring annuity. So that's the first step when calculating the interest portion, okay? So we've got the 160,000 representing our annuity. The next step was to multiply by the present value of an annuity interest factor. Well, we use the market rate at 8%. We use the number of periods at 10. Again, flipping over one more page to page C17, you see the present value of annuity. Don't use the present value of a single sum. This is the present value of annuity. You get the interest factor here of 6.7101. When you multiply these guys out, I'm going to erase just so we have some space. Hopefully you've seen this portion here. When we multiply these guys out, we should get 1,073,616. Okay? Now, the amount, the cash proceeds that we will get from issuing these bonds are the combination of these two. So the combination of the principal portion, which is in present value, dollars now, and now the combination of the interest payments, which are also now in present value. That gives us a total amount of 2,700,000. 16, and like it said in the problem, we round to the nearest 100, so roughly $2 million. Now, why is it $2 million? Well, very simply put, the market rate is equal to the stated rate. Does that make sense? Remember how I told you that if the market rate and the stated rate are equal, it will issue at face value? What is the face value? $2 million. So what did it issue at? $2 million. And even though we didn't have to go through that whole calculation to know that, this serves as a check figure that we've done it correctly. We actually can look at the actual calculations behind it and why it works the way it does. Couple quick things to point out, because this will be helpful moving on with the rest of the scenarios that you're given in this problem, okay? When you're calculating the principal, okay, you use the market rate. Although the market rate and the stated rate are equal to each other in this problem, that's not always the case. Use the market rate. Remember that this is the number of periods, not years. It just so happens that interest compounds annually in this problem. Therefore, the number of years is equal to the number of periods. But interest could compound quarterly, semi-annually, etc. Okay? With the present value of annuity, before you know the annuity, you have to first calculate that interest payment. It is the annuity, right? So, in order to do that, you take the face value times the stated interest rate. Don't use the market rate. Why? The person who issued that bond is contractually obligated to pay the interest rate that's stated on the face of that bond. Therefore, the amount of cash payment for that interest is always going to be face value times the stated interest rate. This gives you the annuity. Then you use the present value of an annuity interest factor, that table 4, using the market rate and the number of periods. Remember when I told you when you're dealing with the interest in terms of time value of money, that's where you're concerned with the market rate, okay? Students often get the market rate versus the stated rate mixed up on when they have to use which. So just make sure you understand that process and use it right, use the right one at the right time, okay? Then when you combine these two together, it gives you, the whole purpose of this problem is to get the cash proceeds of the bond. And why are we talking about this at all? Other than the fact that it's foundation for future classes, the reason why we're talking about this is because remember, the ultimate goal is to find out what is that journal entry where we debit cash and credit a liability, more namely the bonds payable. Okay? Where we debit cash and credit bonds payable, because remember, Chapter 10 is all about liabilities, and Appendix C helps facilitate that to give us the actual amount of cash proceeds. In this instance, it issued at face value. In the future scenarios here, it's not going to be that case. Okay? If you have any questions on this, please let me know. Refer to the next video for EC6 to see the next scenario.